Welcome back, Math 098. We're moving on to adding and subtracting rational functions. Uh, think back to elementary school, and you may remember a teacher saying something about maybe adding fractions. I don't know, I'll say like 1/2 plus 1/4 or something like that. And the whole premise of adding like fractions, if you think about maybe you and a friend ordered a pizza and you ate half, so you have half left over, and your friend ate 3/4 of the pizza, so there's 3/4 left over. So the common mistake I see a lot of students make is they look at this and say, oh, well, if we just do it like multiplication and add straight across, you'd get 2/6, and that couldn't be more wrong. And if you think of the visual I just mentioned with half of a pizza, with 1/4 of a pizza, I think it's pretty evident that, so I'm looking at this piece plus this piece, that you could just piece it together and you're left with 3/4. Well, if you remember back in elementary school, you probably did something where you got the denominators the same, where 1/2 is the same thing as 2/4. So visually, you can see, like, divide the pizza into fourths, and you have 2/4 of the pizza, and your friend has 1/4. So you can squeeze this piece right here, and you can clearly see that you have 3/4 of a pizza. The same thing happens with expressions, with rationals, is you can only add things together if the denominators are the same. So these first couple, the denominators are already the same. It's pretty easy. And then x plus 5x would give you 6x, and then reduce. So 6 divided by 8 would reduce to 3/4, and that x is still there. So as I look at the next one, it gets a little bit more interesting because we do have like denominators. So the denominator stays the same, and in the numerator you get x squared minus 16, but then you're going to do the same thing you did in the previous unit, where you can factor the numerator. Factoring the numerator is a difference of squares, so x plus 4, x minus 4. We can't do anything with that denominator. That stays as x plus 4. But now we can cancel out that x plus 4 because of the multiplication. So if you didn't do section 1, you're probably lost right now. You might want to go back and redo or do for the first time 6.1. So letter B reduces to just x minus 4. Again, I said this quite often in the first one. A good teacher would say that you would also give the domain what x cannot equal, but right now I'm not too worried about it. And then letter C, what's very important with this one is, okay, so the denominators are the same already, but make sure you distribute that z to each, that minus, to each, because you have to subtract the quantity of positive 3, so it makes it minus 3 there. So these two z's will cancel. 1z minus 1z is 1z, but the mistake I see often is students not writing negative 3 over 2a squared. And again, a better math teacher would mention that a cannot equal 0, but I'm not going to mark any of your problems wrong if you don't do that. Only if the directions say make sure you give the domain, We've already talked about that. So as we move forward, we're going to practice the least common denominator. So if you remember, the greatest common factor is the same thing, except least common denominator is in the, well, we're looking at the denominators. So it's the same as the GCF that we found in an earlier unit. So to me, as I'm looking at this, I would find the GCF between the numbers. And we only care about the denominator. Just ignore the numerator for now. So here, I would think about 2 times 3. Well, 9 is the same thing as 3 squared. And if you remember the way we did this before, we identified, like for the greatest common, I kind of have to redo this. That's okay if I made a mistake. Least common denominator. I should have said least common multiple that lesson. It's not the same as the greatest common factor, because the greatest common factor, you only want the common things. With the least common multiple, you want all of them. So you wanted 2 and you wanted 3, and then you want the higher exponent. So higher exponent between 3 to the first and 3 squared is 3 squared. And then x and the higher exponent between cubed and squared is cubed. And the y and the higher exponent between to the fifth and to the fourth is to the fifth. And I'll accept your answer like this. Otherwise, you might rewrite it as, okay, well, 3 squared is 9 times 2 is 18. And I hope you'd all agree that 18 is a multiple of 6 and 9. And we do want to practice the least, otherwise our answer gets a bit busy. And sometimes the least common multiple is just looking at the two denominators and saying, well, nothing's in common, so just multiply. And by the way, multiplying the denominators always works. You just might have more things to factor at the end. So if you wanted to, you could have found a common denominator by just doing 6 times 9 is 54. It is true, but then you would have things to reduce at the end. It's just faster if you do the least common. So on letter B, you just multiply those two together, x minus 2, x plus 3. If you look at letter C, it's definitely a bit busier. And the reason why it's so busy is because you want to practice factoring all of these. So as I look at this first one, and at any point you can pause the video and try to figure these out on your own, or you can just watch mine. That's a difference of squares. Let me change colors for this middle one. Instead of writing b minus 4 twice, it's to your benefit to write b minus 4 squared. Yeah, and then this third one is a little bit more difficult, I would say, because you have that leading coefficient. But it'd have to be 2b times b. Well, there's lots of ways of getting 12. It could be 1 and 12. It could be 2 and 6. Or it could be 3 and 4. Now, to me, 3 and 4 makes the most sense, because if you FOIL, you would have negative 8 plus 3 for the inside term, which would give you negative 5. So I'm guessing and checking. If you don't like my guess and check, then you can do your own way. So you could multiply all the denominators together and get a common denominator. It's just not the least common denominator. So as I mentioned this before, you write down all of the terms, all of the binomials, so 2b plus 3. We have a b plus 4. Well, there's only one of them. And there's only one of the 2b plus 3s. But then there's lots of b minus 4s. We have b minus 4 to the first, to the second, and to the first over here. The highest exponent was to the second. So this would be your least common denominator. And I'm going to do the same work on this last one, or you can try it on your own and see if you get the same answer. So your difference of squares will give you y plus 3, y minus 3. Here I would factor out a 4, and then I'd be left with 3 minus y. And as far as factoring goes, because you want the denominators eventually to be the same, this is just like preliminary work. So I would probably rewrite this with a factored out 4, to make it negative 4. That way this would become y minus 3, which would match up with the other ones. Y plus 3 highest exponents to the first, and then y minus 3's highest exponents to the first. I meant to change colors, but that's okay. So this is, like I said, preliminary work to help us understand how to do complicated problems like this. Because the whole premise is to get the same denominator. And maybe I should have been emphasizing this all along. We want the same denominator so that we can add. So that's why we want to identify that the least common multiple is 5p to the fourth q. 5p to the fourth q. So this is what we would have identified in the previous problem. So the real magic to this is thinking, well, what is this fraction missing to get to this fraction? It's definitely missing a 5. It has 3 p's. Well, we need 4, so we need 1 more, and it already has the q. Well, in order to multiply the denominator by 5p, you also have to multiply the numerator by 5p. So that's where we get 20p. And as we look at this right fraction, 5p to the fourth q, nothing's missing. So there's nothing to multiply that numerator by. So now we can combine them together, and our answer is just 20p plus 3 over 5p to the 4th q. And hopefully this is starting to make sense. You might hear me reference in the future something called the butterfly method, because in this one there's nothing common between the denominators, so you would just have to multiply them together. And maybe you remember the butterfly method from elementary school, where you multiply across. So it'd be 5y minus 12. Notice I'm distributing there. And then you also multiply it this way, which becomes 5y squared plus 15y. And don't bother foiling the denominator. But this is the butterfly method. If you're wondering why it's called the butterfly method, because somebody put a little dot right here to say, hey, there's a butterfly. You multiply the denominators, multiply this way, and you add in between. But you don't have to do it that way. The one thing I do want to point out, though, is sometimes in these problems you can factor. Which I'm going to investigate if I can factor the numerator here. I'm going to change colors, though. Because we can get 5y times y. Well, this might be where, doing that AC method we learned before would be helpful, like negative 60, and then factors in negative 60. That would give me 19. Let's see, it's 15 and 4, right? Except it's 15 minus 4, so that doesn't work. 20 and 3 wouldn't work. Let's see, 30 and 2 would not work. And if you're saying, well, what's wrong with 15 and 4? One of those has to be negative, so that one's not factorable. So I believe that's all we can do with that problem. Let me undo all of those steps. So I'm pretty sure that numerator is not factorable, and therefore this is all you can do with the problem. And again, I keep going back to it, so maybe you guys will get into this habit too, is you should also say what the denominator can never equal 0. Now I do want to point out, on some problems where it looks like the denominators have nothing in common, this is z minus 5 and this is 5 minus z, is if you do a little manipulation, I'm also going to factor out a 3 in that numerator there, is if you just change this by factoring out a negative, that makes it positive z minus 5. Well, now your denominators are the same, and maybe I shouldn't have factored this yet. Let me leave that as 3z minus 18. By factoring out a negative, we can actually change this negative to turn into a plus 3. So the whole point of that, and why I probably shouldn't have factored that, is in the numerator we'd have 3z minus 18 plus 3, so it would be 3z minus 15, and my denominators are the same, so we can just put them together. Same denominator means that we can add them together. Well, now you could factor out in the numerator there. And the reason why I would do that is now with multiplication, because don't forget you could multiply the denominator by 1, we could cancel out the z minus 5s. So this problem that we started that was really, really ugly just simplifies to be exactly 3. 3 divided by 1 is 3. So I've hit the end of my time limit on this. So you might want to hit pause before I close. I do want to point out, though, that I have subtraction problems. I only have 3 more examples to go through, so hopefully the second video is not that long, but here's your next assignment. If you want to try a few problems on your own, and then you could watch the second video in a little bit. But I'll see you then.